the du, we need the du is part of the integral sign. So basically these two parts go together and we integrate the u to the fifth. If it's not, so remember the very first example, it was just an easy, like replace the dx with the du. After that point, it's no longer just an easy switch. So like we had to recognize that the 2x and the dx was what we were going to substitute for du. I don't know, I don't know how else to explain it, just you need it.
I missed the
It
part.
just goes away.
Well, right, because
Yeah.
this means take the these two mean take the antiderivative of what's inside.
I missed the part where we went from using du or dx or dt to determine what we're pointing out, like with change in, to using it as an actual like multiplying by and dividing by and such.
I'm not quite sure what you were asking.
This is cute.
Okay, another way to check your answer, guys, take a look at your result. X squared plus 9 to the 6 over 6 plus c. Take the derivative of this. What would you do? You would take the 6, move it to the front. This, then the 6's would cancel. You get to the 5th power. And then if you're doing the derivative, you have to do the chain rule, 2x. Isn't that what we started with? So you have a way to check your answer here. Isn't it? Okay. Let's try this one. This one,
It's so ugly.
Oh, it's so scary.
what's du?
Why is
Negative
this
sign
negative?
Yes.
I told you.
Okay.
I'm just raw because why this is my passion. That's the problem.
Guys. All right, Natalie, what was your question?
Why is it homesteads instead of ET homesteads?
Okay, so when it's e, when we have an exponential function like e to a power, the inside part is the power.
Okay.
Like if we had e to the 2x, remember when we did chain rule? We were like e to the power times the derivative of the power, because the power is the inside part.
But in the
So-
next one, or like when you have a square root, like the 1/2.
Because the inside changes to what's, that's why I said exponential functions are opposite. That was one of the things I mentioned at the very beginning. Okay, take a look at what we have.
Would it be
Well,
negative to you?
we have a sine, and we have a dx, but there's no negative in front.
Oh no.
Oh no. So basically, we are just going to put it there. Because negative du is equal to sine x dx. Okay? Now, do I really want to put the negative right in front of du? No. I'm going to take that coefficient of -1 and move it all the way to the outside of the derivative. So it's going to look like this.
Or the, yeah.
Okay, now sine x dx. These two get replaced with du, so it's really e to the u du. Remember how I said you always put the du at the end? So if you want to rearrange it so that you have sine x dx at the end and then write it this way, that's fine. Just I told you that was the step that usually I skip
Just right now.
for right now. So do you see how I replaced sine x dx with du plus the negative sign out in front, and e to the cosine became e to the u.
And then it's just E to U plus C.
Right, so what's the antiderivative? It's
Negative
negative e to the u plus c. So now we're just going to rewrite that as negative e to the cosine x plus c. Remember, how do we check our answer? Take the derivative of this. So the derivative of this would be negative e to the cosine x times negative sine x. Negatives cancel, we get back the integrand.
It's a constant. We did it last chapter. Remember you lost then too.
Okay, try the next one. Is this the last one where I show e? Oh, I show what u is? Okay. Yeah.
I don't remember how to do it.
All right.
Oh, no, I got it.
Okay, what's the derivative?
6x squared.
So it's going to be 6.
That's
Oops.
a lot of multiplying.
Sorry.
Also, we'll move the 6 out.
Okay.
Oh no.
So 6x squared dx. Now, I have an x squared and I have the dx, but I don't have the 6.
I'll divide
So,
by six.
I'm going to divide by 6.
Why are we, okay, okay.
Actually, let me,
So we manipulate the du, not the actual function.
right.
Got it.
So, basically what happens is if I'm missing a coefficient or if I'm missing something, it can only be a real number. You can't just like multiply by x on both sides or something like that. If I have a 6x squared dx, but I only have x squared and dx, you have to compensate by dividing everything by 6 or multiplying by 1/6. Does that make sense? So 1/6 du is going to replace my x squared dx.
Yes, you would put the 1/6 like outside.
Right, so let me just, I'll rearrange it because I know. So this is 1/6 du, and this is u to the 1/2. Does everyone recognize that? Right, so the 1/6, the coefficient always gets pulled
In
out
front.
of the, you can technically leave it inside, but I just think it's easier to take it out. No. So I have 1/6 antiderivative of u to the 1/2 du. Okay, so now we have just the power rule again. So it's going to be 1/6, and then it will be u to the 3/2 over 3/2. Now, in terms of the 1/6 getting multiplied to c, we don't have to write plus 1/6 c. Just put plus c. Okay, it's a constant. It doesn't matter that we multiply by 1/6, because it'll still be c. What do we get, men? It'll be, flip it, so 1/9. Okay, so 1/9 u to the 3/2 plus c. So this implies we get 1/9, 5 plus 2x to the 3rd, all to the 3/2 plus c. So don't forget, once you're done, you just have to go back and make everything back into, turn everything back into x.
Can you check this on your calculator?
Not at all.
Not the 84s.
Oh, the email.
Okay. All right, so here's the first one where I do not tell you what u is equal to. But I'm hoping it's obvious. It's not obvious?
It's all.
Well, you only have two choices. It's either 4x plus 3 or the 4. Can't be the dx. And what's inside? Okay, so I'm going to let u equal to 4x plus 3.
But what do we, nothing crosses out.
Okay, so let's see what happens. What's the derivative?
4x, yeah. Of 4.
Just 4. So,
We divide by 4.
so du is equal to 4 dx. Now, I only have dx, so I know that I'm going to have to compensate by multiplying by 1/4. So this here, how do we know what?
You would say, oh, I know how to compensate.
I do, because it's kind of like backwards. You'll see when you get your result why we had to divide by 4 in the beginning, because you're going to end up what's the derivative of the inside? 4.
Yeah.
So I have to compensate by dividing by that 4 in the beginning.
We crossed over.
Because I don't. Let me just. This is u to the 4th. I think we're okay with that, right? I have a u to the 4th. But dx, when I look at dx, it was really du divided by 4. Because du is 4 dx. So I'm going to replace this with 1/4 du. So the 1/4 has to get pulled out in front, and we get u to the 4th du. So what do we end up with when we integrate? 1/4, and then it's going to be u to the 5th over 5 plus c. And then, right, so it's just going to be 4x plus 3 to the 5th over 20 plus c. Now, okay, so if you had to go back, are we okay with that so far? If you were to go back here and do the derivative to check your answer, what would you do? So we'd have, the 5 would move to the front. So you'd have 5 over 20, but you still have that 4 to do the derivative of the inside when you do chain rule, and that has to cancel.
You have 4x over 4, and then you do
So if you check with the derivative, so that would be 5 times 4x. Right, chain rule? So we get the 20s to cancel, check. Does that make sense? Okay, the next one is confusing? Okay, think about, what's the derivative of ln? 1 over x. We have 1 over x. So often it, also, let me just rewrite this. So that makes it seem a little, I think a little more clear to see what is the inside, what's the outside. Just leave it. I mean, if you want, you can. Okay, so the inside, so we're going to let u equal ln of x. So this implies du 1 over x dx. Right here is 1 over x dx. Let me just rewrite it for those of you that want to see it. So I can just kind of change the way it looks, but these two mean the same thing, right? ln of x to the 6 times 1 over x dx. And then you can see, hopefully, clearly, that that's du, and that would be u to the 6. Most of these will turn into like a power rule or just like a trig function. That's our goal. We want to try to, this was all the hard part. And then the easy part is integrating with u. So it becomes u to the 6 du, so we get what? U to the 7th over 7 plus c. And then we just replace, so we get ln of x to the 7th. You can write it on the outside, it doesn't matter. Look good? Is it getting a little better, or is it still confusing? No?
I mean, I got it, but like, I still don't like it.
Like you're just going through the steps, but it's not really clicking?
It's
No,
fun.
I got it, I just
No,
don't
it's
like
fun.
it.
It's fun. It's just a lot. I think it's like a lot of steps.
All right, how about the next one? What's going to be u? I gave a lot of examples because I wanted to. Okay, u, plus I'm writing out a lot of steps. I won't always write out everything, but. Okay, so I have du is 2x dx. I have x dx, but I don't have a 2.
So let's just put a 2 there.
Not a 2, but a 1/2.
Okay,
Close.
that was my second guess. But, so then we do a
Okay, let me rewrite it for you. So I have basically x squared plus 3 to the negative 1/2 power times x dx. So the reason I rewrote it was just so it would be easier to substitute in with u. Okay, so because I have, this was equal to 2x dx, but I don't have a 2 anywhere. So I have to compensate for that by dividing by 2 or multiplying by 1/2. So this gets replaced with the 1/2 du, and this gets replaced with the u to the negative 1/2. So what are we going to do with this 1/2 in front of the du? Move it to the front. So it's gonna be 1/2 antiderivative of u to the negative 1/2 du. Now we just do the power rule. So add 1, divide that by that power. Okay, so, yeah, because we get u to the 1/2 divided by 1/2. So the 1/2 basically cancel. So we get square root of x squared plus 3 plus c. If you wrote x squared plus 3 to the 1/2, that's fine also. Again, these are the types of problems where we've done enough with the derivatives that you can check your answers for these. So you could go through and do the derivative of this, and you would see. Do the derivative of that, and you should get back what you started with. Okay? And obviously, every time you do the derivative, the c goes away, because the derivative of the constant is 0.
The next one, you got me stuck.
Okay.
There's 2 different U's.
Okay. No, this is actually an easy one.
Oh, great.
It just looks complicated. So, which one do you think would be the... So, here's how you check. Just start with 1, okay? This is where I said it's either going to be clear that we picked the right one or the wrong one. Because when you do the derivative, you should find it in the integrand, or at least part of it. So if we do the derivative here, what do we get? 3x squared plus 1. And it's right here. If I didn't come up with 3x squared plus 1, then we'd be in trouble. Then we would have to go back and maybe choose this one to make our u. Does that make sense?
Yes.
So if 1 works, then you're fine. But if you chose 6x or 3x squared plus 1, the derivative of this would be 6x. I don't have any 6x. I wouldn't have a
So it's
way.
gonna match with one of them.
Or at least it won't. Sometimes it won't match exactly like we might.
Manipulate
But you can
match.
manipulate it with a coefficient. So if you want, do you need me to rearrange it, or are you okay here? So this is really just u squared du. That's why I said it looks more complicated than it is.
Yeah, I'm actually.
So it becomes u to the 3rd over 3 plus c, which implies we have x to the 3rd plus x all to the 3rd over 3 plus c. Are you really? Really?
Yeah, I did.
It was a really tiring weekend.
So now once with the identities it gets harder, I think it's time to stop and come back tomorrow.
Can I just show you one? Okay, I'm not going to ask you if I can. I'm going to show you one more thing. Let's skip the trig identities for now. We'll continue those. I want to show you just changing the bounds. Just it's for those of you that want to work it, because you have one homework assignment for 2 days, and I know some of you have more time one night than the other.
Don't we just find
Okay.
the integral and then do it from the bounds?
Okay, so basically, I like just, if you change everything to u, these bounds, 0 and 1, go with the variable x. So if we change everything to u and change the bounds, then we can just solve it with u. It makes it easier.
Wait, what?
Okay, let's just do u substitution. Let's look at, okay, we have choices here. We can either make our u equal to the x or the x squared minus 4.
X squared minus.
I'm going to say, let's make u equal to x squared minus 4.
We should always make it the one where the x is to the highest power, so that when we
Right.
take the derivative, it gets lower.
Right. So what's du? Okay, I have an x and a dx, but I don't have a 2, so I'm going to have to multiply everything by a half. Okay. So I'm going to rewrite this. Don't put the bounds in yet. This is going to be 1/2 out in front, 1 over u to u. Let me pause there for a moment, make sure.
Didn't put in the 0 and 1.
Ah, I know. I don't put in the bounds yet.
Done. Thanks, Paul. Perfect.
Now, I'll tell you that there are two different ways to do this. You can just integrate this and then go back, plug x back in and use 0 and 1, or we can change the bounds to work with you.
Yeah.
So,
Yeah.
I'm going to show, you have to know both. You have to know how to do it this way, because there'll be questions on the AP that you can only use with the kind of substitution. So let's put in the lower bound. Originally it was 0, but if I'm changing everything to you, plug 0 in for x, what do we get?
-4.
So my new lower bound is -4.
So we plug in the lower bounds to you, plug in bounds to you,
Right.
plug in the bounds to you.
So what's the upper bound?
Yeah.
Okay. Do you remember what 1 over u is, or u to the -1? ln of absolute value. And we want to evaluate this from -4 to -3.
Good thing we have absolute value.
Good thing we have absolute value, otherwise it wouldn't
What
work.
about plus C?
No,
We don't need plus c anymore because we
Because we
have
have-
the bounds.
Yes, we do.
So we have 1/2, it's going to be ln of 3 minus ln of 4. See, we didn't have to go back and plug x back in because we changed the bounds. So since the bounds now reflect our variable u, we can just plug them in as is. And then if you want, you can actually just, I'll just put or.
Oh,
It's fine. Hopefully if you saw that as a multiple choice question and they had it written differently, they could have also gone further with the power rule. Okay, I just wanted to show you that one example, so at least those of you that move on. The homework actually, it looks like a lot, but the first ones are going to be reviewed from the last chapter. It's just to be really quick, like power rule plus C. It's stuff that we've already done. And you do have 2 days to do it, so